Okay, if I want to compose the functions f and g of x, right? F composed with g of x, we learned in our last video, is the same as f of g of x. We take g of x and we substitute it in to the x for the function f. So that would be the same as f of g of x, and g of x is 5x minus 6. Okay, the function f is 3x plus 2. So I'm taking this f of x and I'm putting it in for this x in 3x plus 2. Right? This is what's going to be substituted with 5x minus 6. So we're taking this 5x minus 6, we're putting it in here for the x. So we have 3 times the quantity 5x minus 6 plus 2. Okay, now if I wanted to compose g with f of x, that's g of f of x. So this time I'm taking the function f of x and I'm putting it in for the x in g of x. Okay, that means now that I'm taking this the other way. So I'm going to take 3x plus 2. There we go. So I'm going to take this 3x plus 2, and I'm going to replace the x in 5x minus 6 with that 3x plus 2. So I have 5 times the quantity 3x plus 2 minus 6. See how we're taking this 3x plus 2 and we're substituting it for the x in g of x. And that's how you compose your functions in terms of x. So let's look at example 3 together in the notes. So I'm going to take my function f, which is 8x plus 3, and I'm going to compose it with the function j, which is 1 over x. So I've got f of j of 4. So that's f of, and now I'm going to take my function j, which is 1 over x, but instead of x, we're putting in a 4. And now that means I'm going to take this 1/4 and substitute it in for the x in the function f. So I'm now evaluating there. So I'm now evaluating 8x plus 3, but instead of the x there, we're going to put in the 1/4. So 8 times 1/4 is 2, plus 3 is 5. So now in example B, we have h composed with g of 1/2. So I'm going to use green for h, and we're going to compose h with g, which I'll make in purple, and g is going to be evaluated at 1/2. So now we're going to take h, and we're going to evaluate g of 1/2. So we put a 1/2 in here for x. So that's 2 times 1/2, then minus 10. So we've got 2 times 1/2, which is 1, minus 10 is negative 9. So we're evaluating h of negative 9. And h is x squared. So we're going to evaluate negative 9 quantity squared. And as you can see in the calculator, when we have parentheses, which we do around that quantity negative 9, and we square it, a negative times a negative is a positive 81. So it's very important that you remember to put those parentheses around that input of negative 9, because the x includes the negative. Right? Negative 9 is the x, which gets squared. So the negative gets squared, making this answer a positive 81. Okay, then next we have f composed with g of x. So our outside function is f, and our inside function is g. And we're going to evaluate these in terms of x, this composition. So that's taking the function f and substituting in the function g, which is 2x minus 10. So our function f is 8x plus 3. So we'll have the 8, we'll leave a space for the x, plus 3. And in place of that x, we're putting in 2x minus 10 from our function g. Now, when we distribute to get rid of those parentheses, right, we've got 8 times 2x is 16x. 8 times negative 10 is negative 80, and then our constant plus 3. So that's going to evaluate to 16x minus 77. Okay, then last we have g composed with f of x. So our function g is on the outside, and our function f is on the inside this time. So we want to evaluate g of, and then f of x, which is 8x plus 3. So in our function g, which is 2x minus 10, we'll put the 2, we'll leave some space for the x, minus 10. And in that space for the x, we replace that x with 8x plus 3. So now as we distribute, to get rid of those parentheses, we have 2 times 8x, which is 16x. 2 times positive 3 is a plus 6, and then minus 10, and that's 16x minus 4. Okay, go ahead and pause the video and try these 4 on your dry erase board or on scrap paper, and when you're ready to check them, you can resume the video. So in A, we have f composed with g of x. That's f of g of x. So we're going to take the function g, 5 minus 4x, and put it in as the argument of the function f. Okay, the function f is 6x minus 1. So we're putting in that 5 minus 4x for the x in 6x minus 1. Then we're going to distribute to get rid of those parentheses, and we'll have 30 minus 24x, then our minus 1, and we combine our like terms to get negative 24x plus 29. In B, we're composing g with f in terms of x, so now we've got g of f of x. So we're going to take this red 6x minus 1, we're going to put it in for the x in g of x, which is 5 minus 4x. So we've got 5 minus 4 times the quantity 6x minus 1. Again, we need to distribute to get rid of those parentheses. We have 5 minus 24x plus 4. And then when we combine like terms, that's a negative 24x plus 9. Okay, next we have g composed with h of 9. So this time we're going to evaluate g of h of 9. So we take the 9, we put it in for the x in h of x. The square root of 9 is 3. So then we'd be evaluating g of 3. G is 5 minus 4x. We're going to replace that x with a 3. So we have 5 minus 4 times 3. Then 5 minus 12 gives us an answer of negative 7. F composed with j of 4. That's f of j of 4. So we're going to go up to our function j and put in a 4 for the x. 2 divided by 4 is 1/2. So we're evaluating f of 1/2. So we go up to our function f, 6x minus 1. We're going to substitute 1/2 in place of the x. So that's 6 times 1/2, which is 3, minus 1 is 2.